Hello everybody and welcome to Blockchain Expert. In this video, we'll be discussing blocks. Now we've already talked about transactions, wallets, decentralization, ledgers, and a few other aspects of the blockchain network and what a blockchain is, but in this video we're actually going to explain why it's called a blockchain. So we've already kind of seen that we have blocks, and blocks are what are storing our transaction data and a few other pieces of information as well, and we know that they're linked together. But here I'm going to break down exactly what's stored on each individual block and how these blocks are linked. So with that said, let's go through a quick recap here of some of the previous videos and the stuff we've learned, and then we'll get into the composition, or I guess the properties of a block. So as we know, we have a blockchain. Now the blockchain really is just a sequence of blocks that are linked in chronological order. Now, these blocks are going to be storing different transaction data, and they're essentially storing a log of every event that's ever happened on the blockchain, because a transaction is really just an event or something that's occurring on the blockchain, and we're logging that and then linking all these events or linking all these blocks together. So the way that we actually create a block is we start by having a transaction pool. Now, this transaction pool is going to have a bunch of transactions that have been submitted but have not yet been verified. And then we're going to have a bunch of miners. Now, I'm just going to represent the miners with a bunch of blocks here. Just imagine these are all computers. So we have our miners. What the miners do is they look at the transaction pool, they collect a bunch of transactions, and then they attempt to create a block. Now, if they successfully create a block, and that's what we're going to talk about in a few future videos, then what happens is this block gets submitted to the blockchain and it gets added to the chain, assuming that there's no issue with this block and that this block gets removed, which can happen if this was, say, a fraudulent block. Again, we're going to get to that in a future video. So that is a very quick recap and summary of what goes on here, but what is actually on these blocks? That's what I want to talk about now. So let's clear the screen and let's start going through what makes up a block. I'm just going to put some points on the screen as I go through it. So the first thing that we have on a block is a magic number. Now, a magic number is just a specific number that's going to be a constant value for all of the blocks that identifies this block as a part of a specific blockchain network. So if we're talking about something like Bitcoin, it has a specific magic number where all of its blocks contain that number, and that identifies them as a part of the Bitcoin blockchain. Now, the reason we would have something like this is because obviously we have many different blockchain networks, and even if we talk about something like Bitcoin, we would have the main production Bitcoin network, and then there may be a test network that developers are using to test out different features. Same thing with Ethereum, same thing with a lot of other networks. We usually have a few test networks that people can play around with for free, and then we have the actual production network. Okay, so that is the first thing, our magic number. So the next thing we have here is the block size. Now, the block size is just the size limit of the block. That doesn't mean that it's always going to be taking up whatever this block size is. It just means that's the maximum amount of data that can be stored in a single block. Now, for Bitcoin, this is 1 megabyte. Now, this is a huge debate because increasing the block size would allow more transactions on each block, but there is some downsides that come with that. And again, we're going to get into that stuff in later videos. For now, though, understand the block size is just the maximum amount of data that can be stored. And for now, on a single block on the Bitcoin network, it's 1 megabyte. So if you actually conceptualize that, that's not that much data when we're talking about millions or maybe hundreds of millions of people using the Bitcoin network. And that can be a reason why it can be quite slow to actually submit transactions, because there's just not enough size to store all of the transactions on the current block. And you may have to wait many blocks into the future before you actually get your transaction onto the network. Anyways, that is the block size. The next thing that we have is a block header. Now, the block header just contains a bunch of metadata about the block. I'm not going to get into that metadata because it's not very important. Just understand that we do have a block header. Next thing that we have on our block is a transaction count. Now, this is just the number of transactions that are stored on the block. Pretty straightforward value, just stores the number of transactions. So the next thing we have here after the transaction count is transactions. Now, this is going to be the bulk of the block, which is just all of the transaction data that is a part of this block. And that transaction data is what I talked to you about previously in the last video. Continuing, we have the version of the block. So the reason we'd have that is sometimes blockchains can be upgraded to, say, a version 2 or a version 3, whatever the version number may be. So, of course, we're going to store that. So after the version, we have the previous block hash. Now, this is very important because this is what actually links different blocks together. And I'll just draw a quick diagram over here on the right-hand side of my screen. So let's say we have block 1, and then we have block 2. Now, these blocks are linked together, but the way that they are linked is that this block, so the second block in the chain here, stores kind of an entry or, I guess, a reference to this previous previous block. Now it does that by storing the hash of this block. So what we would do is we'd take this block, we'd run it through some hash function. So let me just say hash like that. And then it's going to give us a random string of characters. We don't really know what that is. I can just write something for now so that we can use this as a reference. Let's just say AB2. Now, of course, this would be much longer and much more complex, but for now, we'll just pretend this is the hash of this block and all of the data inside of it. So what this block does is it stores on here the previous hash of AB2. So now when I'm on this block, if I want to know what the last block was, I just look for this previous hash and I can verify that this was the previous block. And the way I can actually do that as well is I can then rehash this block and I can make sure that the hash of the previous block is the same as what's being stored on this block. Now, what that also means, and we're going to talk about this in some future videos, but I want to give you kind of a teaser or a hint at what's happening here, is that if I were to change any of the data on this block, so let's say I change this transaction, I'll indicate I'm changing it by drawing it in green. What happens is this hash completely changes. Now maybe we have CB3, whatever. We have a different hash now. So now this block no longer becomes valid because it's not linked in the blockchain. It doesn't have a valid previous hash, and now we would have to recompute the hash or kind of recreate this block to make it be valid in a blockchain that has this block with a changed transaction. Now, I know that may seem a little bit confusing, but the whole point here is that if I change any data in the previous block, that actually is going to change what should be stored in the next block. And again, that's a massive kind of security implementation or security feature of the blockchain, is storing this previous hash. And then you could extrapolate this and imagine that when we go to the next block, well, we're storing a hash of this block. So now if this changes, this previous hash changes, which means now the previous hash here changes, and you can continue that on and on and on. So anyways, I'm sure that's not completely clear, but I just wanted to give you a quick teaser of what's going on and why we would store the previous block hash. All right, so after that, we have something that I'm not really going to explain very much, which is called the hash Merkle root. Now, again, this is a pretty complex topic that we don't need to get into here, but the way that some validation is done with different transactions on blocks is using something called a Merkle tree. Now, a Merkle tree is essentially a quick way to determine if a transaction is a part of a specific block and if it is valid. Again, I don't want to get into it too much. You can imagine this kind of like a binary tree, except it's storing different hashes. And anyways, what we store on the block here is something called the hash Merkle root, which is the root value of the Merkle tree. Again, not going to get into this too much. It's a pretty complex topic and it's completely unnecessary to go into, but I just want you to know that there is something called a hash Merkle root that is a part of every block. All right, continuing on the block, we also have a timestamp. This is when the block was created and added to the blockchain. Next, we're going to have something called bits. Now, the bits is actually going to be the difficulty rating of the block. Now, we can have something like 10 bits or 20 bits or 30 bits or 40 bits, and as the bits increase, the difficulty of the blockchain increases, and what that means is it becomes more difficult to mine a block. So that's what we're going to talk about in proof of work and proof of stake, kind of how this difficulty rating works and how that changes the difficulty when you increase the number of bits. But for now, just understand that the difficulty is stored on there in a field called bits. Now, after that, we have what's referred to as the nonce. Now, the nonce is a special number that is determined by miners, and that's actually what proves that this block is valid and that a certain amount of work has been done to validate the block. So this is kind of something that's added to the end of the block by a miner, and this is their proof that they're submitting to the blockchain to indicate, hey, I've done a sufficient amount of work and I've proved that this block is indeed valid. Now, again, we're going to talk about that in a future video, so don't worry about it too much, but just understand we do have a value called the nonce, and the nonce will be generated by the miner and kind of added onto the block to satisfy some specific properties that we'll get to later on. Now, the very last thing that we have on the block here is the block reward. Now, this block reward can change, and typically it decreases as the network gets older, but this is how much Bitcoin is going to be given to the miner that successfully mines the block. So this is what encourages miners to participate in the Bitcoin network, is that if they are able to validate a block and submit one to the blockchain, they will be given whatever the reward is. Now, just as an interesting fact here, back in 2009, when the first Bitcoin block was created, that had a reward of 50 Bitcoin. So if you were the one to mine that very first block, you got 50 Bitcoin, which now obviously is a very large number in terms of US dollars. Continuing though, in 2012, this reward was halved to 25 Bitcoin. Then in 2016, it was halved again, going to 12.5. And in 2020, it was halved another time down to 6.25. So every approximately 3 or 4 years, it's a certain number of blocks, but I don't have that number on hand. This value is halved, and this is predictable. So you can go and look at approximately when it will be halved again, and you can predict relatively what the reward is going to be in the future. You can look at it today. Currently, the reward is 6.25 Bitcoin, and you can do this for pretty much any blockchain network. All right, so that is all I had to talk about for what is on a block. The next thing I want to do is talk to you about the first block in the blockchain, because this is a special type of block, and it's kind of an initialization block that has some different properties. So just to recap here, on a regular Bitcoin block, so one that is not the very first block, you have a magic number, a block size, a block header, transaction count, all of the transaction data, previous block hash, you have the hash Merkle root, you have a timestamp, you have the bit, which is the difficulty, you have the nonce, and then you have the reward in Bitcoin that is given to the miner that successfully mines the block. So as I was saying, now let's talk about what the first block is in a blockchain network, specifically what the first block is on the Bitcoin network. So the first block on the Bitcoin blockchain network is referred to as the Genesis block. Now this is really just the starter block, the initialization block, whatever you want to refer to it as, but the official name is the Genesis block. Now, this block contains all of the data that I talked about for a normal block, so the magic number, the block size, etc. It has all of that, but it also has a few additional properties that kind of define the start of this blockchain and list out a few properties. So the first thing that's going to be listed here on this Genesis block that's different from our other blocks is it's going to define the difficulty currently and the difficulty interval. Now again, remember the difficulty is just the number of bits. That bits has to do with how difficult it is to actually mine the block, so we'll talk about that later. But the Genesis block will define the difficulty, and it will define that interval, so how the difficulty is increasing or decreasing, and that can be something relatively simple, like it can increase every X blocks, or it can be based on the volume of the network, so how many miners are on the network, etc. So I won't talk about that too much because, again, it's a little bit beyond the scope of this current video, but just understand it defines the difficulty and it defines how that difficulty is going to increase or decrease based on either a very simple formula or something that's a little bit more complicated. Continuing, the Genesis block is also going to define the reward for mining. So it's going to define what the current reward is. So in the case of Bitcoin, the Genesis block defined 50 Bitcoin. It's also going to define how that reward changes over time. So it can be something like the reward will change every X blocks. It will be something like the reward is constantly increasing or decreasing. There's all kinds of different ways to do this. Again, it depends on the blockchain network. Now, the thing with this is that this reward is a new coin. That's what you have to keep in mind. Every time someone is rewarded with Bitcoin or rewarded with whatever the reward is for a blockchain network, that is a new version of the coin. It's a new instance. So you're creating more. You're increasing the supply or the circulation of this coin. Now, the reason why it's important to define the reward and define how that reward changes is so that, again, it's predictable how many coins are going to be in circulation at a certain point in time. Now, in some blockchain networks, it reaches a point where there will actually be zero reward, and the only reward that will be given to miners is the transaction fees that they're picking up when they're actually assigning transactions or adding those to a block. So just keep that in mind. Usually when you talk about cryptocurrency, they are deflationary in nature, but there is some cryptocurrencies where they would have very large rewards, and that would continue to increase the supply of coin, which would then devalue the currency. And this is similar to what happens when large central banks go and print a ton of money, right? They're increasing the supply of money, they're increasing the availability, and that then devalues the currency, and usually the price of different items, commodities, etc. goes up. Anyways, after we have the reward and how that reward changes over time, we have a definition of the amount of coins that are circulating. So essentially the supply of coins. So when we talk about something like Bitcoin, there's a set number of coins that will ever be in circulation. So the maximum possible circulation of coins for Bitcoin is 21 million. Now, what that means is that there's never going to be more than 21 million Bitcoins in circulation. Now, currently today, there's about 19.1 million Bitcoins in circulation. Now, that's a rough estimate. When you're watching this video, it could be different than that, but approximately every 10 minutes, which is how long it takes to create a new block on the Bitcoin network, 6.25 Bitcoins are being added into circulation. So you have to remember that the reward is new Bitcoin that's being created or added into the circulation. So currently, if we're at 19.1, then that means over time, that number is going to increase based on what the reward is. So since you know what the reward is, you know approximately how long it takes to create a block, and you know what the maximum circulation is, you can determine at really any point in time, okay, this is how many are currently in circulation, and this is how long it will be before we reach 21 million or before we reach whatever the number is. So just to continue here slightly about the Genesis block. So what happened was when this Genesis block was first created, Satoshi, who was the only one who probably knew about Bitcoin at this point in time, was the one mining this block and mining many subsequent blocks. So as soon as he mined that first block, he received a payout of 50 Bitcoin. Now at that point in time, after the first block was mined, there was only 50 Bitcoin in circulation. The maximum amount that could be in circulation is still 21 million, but only 50 has actually been minted or created because he's the one who mined that block and he received that reward. So continuing, he would mine many, many blocks and receive continually more Bitcoin reward. So as time goes on, obviously more Bitcoin comes into circulation. And now, as we see, Bitcoin is coming into circulation much slower, and it's obviously a much more valuable asset. Now, anyways, I just wanted to quickly touch on that. When Bitcoin first starts, before block 1 has been mined, before the Genesis block has been mined, there's 0 Bitcoin in circulation. Then that block is mined, then there's 50. The second block is mined, then there's 100. And that continues until eventually you reach the supply of 21 million, and then there's no longer a block reward, and instead you're just picking up transaction fees and continuing with the network. All right. So with that said, I think I'm going to wrap up the video here. This was meant to just talk to you a bit about blocks, explain the data that's actually stored on those blocks, and then again, talk about kind of the foundation or beginning of the Bitcoin blockchain network, how the circulation of coins works, and how new coins are created. Again, all of this is specific to Bitcoin. On different networks, it's going to work slightly differently, but usually the fundamentals and the basics are the same. So with that said, I hope you enjoyed this video, and I look forward to seeing you in another Blockchain Expert video.